Okay, in this video we are going to work on the 6-5, which is a 6-4 practice page from, which geometry was that? From our geometry book we used to use a few years ago. And this is about properties of rhombuses, rectangles, and squares. So for these pages, if you want full credit, you need to do all the odds. We'll do, some of each, but probably not all of them. So let's talk about these. Let's look at number 2. Number 2 is a quadrilateral that has all sides congruent, and which makes it a rhombus. But also it has right angles. So a rhombus with right angles is a square. So square is the best answer for number 2. Now if we look at number 3, all the sides are congruent. That's by definition a rhombus. This would be a rectangle, opposite sides congruent and right angles. This makes it a rectangle. Okay, so here we look at number 4. We got parallel sides that are both parallel and congruent. By definition, that's enough to be a parallelogram. But also, we have a right angle, and then by same side interior angles, that's going to be a right angle. Since let's see, since in a rectangle, these sides are going to be parallel to each other, and then you get same side interior angles this way, and also same side interior angles this way. So one right angle basically can be jumped around to show that all the angles have to be right. So what we actually have here is a fancy version of a rectangle. And then look at number 5, we have a rhombus. So even though they might not look it, they're telling us with these tick marks that those sides are congruent to each other. Okay, let's do a couple of these. So you're going to need to do the odds, remember. So let's we'll talk about like number 9, and we'll do number 10, and let's do number 12. Okay, so these are the ones you need to do, and we'll do some of them. So we'll do number 9, we'll do number 10, and we'll do number 12. So see what we got. They're all kind of different. So let's do number 7 first. So number 7, by the markings, we have a rhombus. Now by definition, the diagonals of a rhombus are perpendicular bisectors of each other. So I'm going to mark it up with the properties that I know a rhombus has. Also, a rhombus is a parallelogram. So opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. And also the angles are bisected. So these 4 angles at the more acute tips, which end of the major axis, those vertex angles are congruent to each other, and 2 and 3, and this angle and this angle and this angle and this angle. These angles are all congruent to each other. So all of these are going to be 68s. All of these are going to be are whatever's left over after we do 360 minus 268s. It was 268s. Because altogether this is a quadrilateral, so it has to add up to 360 degrees. This is a 60. Oh wait, yeah. This one angle is a 68. So this other angle is a 68, and angle 2 and angle 3 are also congruent. So we actually have 4 angle 68s, not 2. So let's see what we got here. 360, and 4 times 68 is 240, plus another 48 is 288. No, I didn't do that right. 4 60s is 240. 4 8s is 32, so that's 272. So 360 take away 272 is going to be something like 88, I think. Let's check this. Yeah, so it's going to be 88. So these four angles need to make up what's left of the 360, which is 88 degrees, after the 468s suck up all the angles out of 360. 88's what's left over. There's four of them. Divide by 4. Each one of those angles is 22 degrees. Okay, so we found them all. Angle 1 is going to be 22. Angle 2 is going to be 68. Angle 3 is 68. Angle 4 is 90. And those are the angles. Number 9 is similar. I was going to do 9, but I did 7 instead. Okay, 9 is similar. 52's there. 52's there. Add them all up. Subtract from 360. Divide by 4. You get each one of those. Since it's a rhombus, these are going to be right angles. Okay, so you need to finish that up. Same thing for number 11, pretty much. 29, 29, 29, 29. And then these are 90s. Number 13, see a 90 there in the center. Angle bisected. Okay, this is a little bit trickier. You got to kind of think about what's going on. These are 4 congruent triangles. You figure they're right angles. Here's a hypotenuse. These diagonals are perpendicular bisectors of each other. So these congruent triangles are basically going to let us know that these corresponding angles are congruent to each other. Okay, let's move on. Let's look at these algebra ones at the bottom here. Look at which one are we going to do? Let's look at number 14. So talking about HIJK is a rectangle, so they don't give us a diagram, so we need to supply one. We need to get used to doing that. So this is going to be a rectangle, opposite sides congruent and parallel, and also remember there's right angles. So we have this marked up as a rectangle, and it's HIJK. Make sure we know what they're talking about. Now on this one, there's an HJ, which is this diagonal here, is equal to X. And the other diagonal, they're telling us, is IK, which is this one through here, is 2x plus 7. So, or 2x minus 7. And since this is a rectangle, the diagonals are congruent to each other. So we have 2x minus 7 has to equal x. Take away 2x from both sides. Minus 7 is going to be minus x. Multiply both sides by -1 to find out what x is. 7 is equal to x. So x is equal to 7. Now it wants us, so we found x. X equals 7. It also wants us to find the length. The length of each diagonal is 7. So HJ is equal to IK. The distance from HJ is equal to the distance from I to K, which is equal to 7. Let's talk about setting number 17 up. For this one, they're saying that HJ, which is this diagonal here, is 3x plus 5. Is 19 plus 2x, and IK is 3x plus 22. So these need to be set equal to each other and solve for x, and then plug back in, just like I did for number 14. Same thing for number 15. You set these two equal to each other, solve for x, plug it back in. So in a rectangle, the diagonals are congruent. Okay, let's continue on. Remember, okay, still need to do the odd ones on the back side here. Just circle some of these. So these circled ones are the ones, if you want full credit, that you need to do. Let's look at some of these. Let's look at 27 to begin with. Okay, they're telling us it's a square. So since this is a square, all the sides are congruent, which means that this x plus 7 side must be equal to the 3x plus 1 side. And then you can solve for x. Let's look further up. 25, they're telling us we have a rhombus. In a rhombus, all the sides are congruent. So m plus 12 is equal to 3m. Set those equal to each other, just like 27. You can solve for m. And then plug them back in and find out what the side length is. 20 through 23, we want to name the most precise name. So you should be able to see that this is marked as a rhombus with right angles, which makes it a square. And this is a rhombus. And number 19, these diagonals now, one's x plus 40, the other's 5x, like the ones on the other page. You set them equal to each other and solve for x. And then find the length of the diagonal also. So let's see what else is there. So let me do a couple of these over here. Looking at 22, opposite sides congruent and right angles. That makes this a rectangle. Here we have opposite sides congruent, nothing else special. This is just a parallelogram. Uh, 24, this is a square, so these opposite sides are congruent. So 3/5 x equals x minus 8. Now I would multiply both sides by 5 to get rid of this fraction. So I'm left with 3x equals 5x minus 40. Remember, everything gets multiplied by 5 on the other side. Well, everything gets multiplied by 5. It cancels out here. And 5x minus 40 on the other side. Take away 5x from both sides. Minus 2x's equals a negative 40. Divide by negative 2, x equals 20. Okay, find the values of the variables and find the side lengths. So 20 take away 8 is 12. So each one of these sides is going to be 12. And if we did 3/5 of 20, we get 60 over 5, which also is 12. Same thing with this one. We talked about that. You set them equal to each other. Let's see. Let's do number 18. Okay, these two diagonals need to be congruent. So 4x equals 7x minus 12. Take away 7x from both sides. Minus 3x's equals negative 12. Divide by negative 3. X equals 4. And we also need to find the length of the diagonal. 4 times 4 is 16. So 4 and 16 are the two answers they're looking for number 18.